The Type ZC U-boat that slipped beneath the Atlantic surface on March 15, 1943, carried what German Naval Command believed to be perfect stealth technology, until American radar operators began tracking every submarine movement from 200 miles away. The Marine called their submarines Gray Wolves of the Deep. The Americans would soon have another name for them: Sitting Ducks. March 15, 1943. 0300 hours, 400 miles southwest of Iceland. The German U-boat U-247, under Captain Lieutenant Heinrich Wolf, had just begun what should have been an invisible approach toward Allied convoy HX-229. The submarine's hydrophone operator reported clear water ahead, no destroyer engines, no escort vessels within detection range. According to every calculation in the Marine's tactical manual, U-247 was completely undetected. Yet at that exact moment, 180 miles away aboard the USS Bow, aviation electronics technician First Class Robert Radar Bob Patterson was staring at something impossible forming on his ANAPS-20 radar screen. A faint blip, barely noticeable against the Atlantic's electronic noise, but moving in a pattern no surface vessel could make. Patterson tightened his scope's gain and called out to his supervisor. "Chief, you need to see this. I've got a submerged contact at bearing 270, range 180 miles. What Patterson was seeing was the result of 18 months of secret development at MIT's Radiation Laboratory. The ANAPS-20 search radar, mounted on specially modified TBF Avenger aircraft, could detect the tiny radar echo produced when a submarine's conning tower broke the surface for only a few seconds during periscope checks or battery charging. The Germans had no idea such technology existed. Gross Admiral Karl Dönitz, commanding the U-boat fleet from his headquarters in Lorient, France, had spent 2 years refining what he proudly called Rudel Tactic Wolfpack tactics. His entire strategic doctrine assumed Allied detection capability extended no farther than 10 to 12 miles, even under ideal conditions. German intelligence had captured Allied destroyers and inspected their radar systems. They knew about the Type 271 surface search radar and the HF/DF radio direction equipment, but they knew nothing about airborne centimetric radar operating from 10,000 feet with detection ranges exceeding 200 miles. U-247's crew pushed forward on their approach, following the same procedures that had already sunk over 3,000 Allied merchant ships. At 0347 hours, Wolf ordered the boat to periscope depth for a routine navigation fix. The periscope broke the surface for exactly 47 seconds, long enough for the steel conning tower to bounce electromagnetic waves straight back to Patterson's radar antenna. Minutes later, 4 TBF Avengers launched from the Bogue, each armed with depth charges and fitted with the same groundbreaking radar that had exposed U-247's position. The aircraft swept in with a coordinated search formation, their radar operators tracking the submarine's every move beneath the waves. At 0420 hours, Lieutenant Commander James Mitchell, leading the Hunter-Killer Group, radioed the Bogue. Contact confirmed. Submerged submarine bearing 268. Estimated depth 60 feet. Speed 4 knots. Beginning attack run. U-247 never saw the aircraft approaching. The crew's first hint of detection came when depth charges detonated in a perfect ring around them. Within 18 minutes of rising for the navigation fix, U-247 was forced into an emergency surface, her pressure hull cracked and flooding fast. Wolf's final radio message, intercepted by Allied listening posts, captured the chaos in his voice. Under attack by aircraft. No surface contacts detected. Impossible accuracy. Request immediate assistance. The age of invisible submarines had ended in the North Atlantic, though the Marine would not understand why for months. The German U-boat force dominating the Atlantic shipping lanes in early 1943 represented the most advanced submarine warfare system ever engineered. Gross Admiral Karl Dönitz commanded 400 operational submarines, staffed by crews who had honed stealth combat through 3 relentless years of war. German submarine design had progressed far beyond Allied predictions. The Type 6C boats carried double hull construction to reduce noise, electric motors for silent movement, and hydrophone arrays sensitive enough to pick up convoy engines at 50-mile ranges. Each vessel carried 14 torpedoes and could remain submerged for up to 20 hours during operations. But Dönitz's greatest breakthrough was tactical, not mechanical. His Wolfpack doctrine grouped 15 to 20 submarines in coordinated attack formations across convoy routes. The system depended on exact intelligence gathering and communication methods refined over years. German B-Dienst cryptanalysis teams working from fortified bunkers in occupied France intercepted and decoded Allied merchant communications. They knew convoy departure schedules, routes, cargo loads, and escort patterns before the ships even left port. This intelligence reached U-boat captains through Enigma-encrypted radio transmissions that German cryptographers believed were mathematically unbreakable. Kapitän Zerzate Eberhard God, Donitz's operations chief, had reduced submarine warfare to mathematical precision. German intelligence estimated Allied detection capability at only 8 to 12 miles under ideal conditions using ASDIC sonar. Wolfpack tactics kept submarines well beyond this range until the final attack phase. The sequence itself had been perfected through hundreds of successful operations. Submarines held positions 50 miles apart across convoy routes. When merchant ships were spotted, the U-boat that made contact would shadow the convoy while transmitting position updates to pack headquarters. Additional submarines would then converge from preset locations, closing in from multiple directions at once. Night surface attacks allowed U-boats to exploit their superior speed and maneuverability while staying invisible to Allied radar. German submarine commanders had studied captured British radar systems and understood their weaknesses. The Type 271 centimetric radar mounted on escort destroyers could detect surface ships at 15 to 20 miles, but submarines running on the surface produced extremely small radar profiles. Submarine yards in Hamburg, Bremen, and Kiel were turning out new boats faster than the Allies could sink them. By March 1943, German shipyards launched a new submarine every 3 days. Each one required 18 months of construction and represented the peak of German engineering skill. The crews were the elite of the Kriegsmarine. Service required volunteers who completed 8 months of specialized training at the submarine school in Neustadt. They learned to operate in tight quarters for weeks, to remain silent during depth charge attacks, and to execute complex torpedo firing solutions while maneuvering at high speed. Donitz's headquarters calculated that sinking 600,000 tons of Allied shipping every month would eventually force Britain out of the war. By early 1943, German submarines were destroying 400,000 tons of Allied shipping each month, with what Donitz considered acceptable losses, typically 8 to 12 submarines out of a 400 boat fleet. The mathematics favored Germany. British shipbuilding could not replace vessels at the rate they were being sunk. American Liberty ship production was rising, but German submarine production was rising even faster. What German intelligence failed to anticipate was the revolutionary detection technology being quietly deployed aboard American escort carriers in the North Atlantic. The weapon that would transform submarine warfare had been born out of urgency inside a converted warehouse at MIT's Radiation Laboratory in Cambridge, Massachusetts. By September 1942, U-boats were sinking Allied merchant ships faster than shipyards could build them. Dr. Luis Alvarez, leading a team of 37 engineers and physicists, received a classified directive: develop airborne radar capable of detecting submarines beyond visual range. The breakthrough came from understanding electromagnetic wave behavior at frequencies previously untested. Traditional Allied radar operated at around 200 MHz, producing wavelengths far too long for precise contact with submarines. Alvarez's team designed the ANAPS-20 system operating at 3,000 MHz, 10 times the frequency, with vastly superior resolution. Technical specifications and Navy Bureau of Aeronautics records outlined the system's unprecedented abilities. The magnetron transmitter generated 50 kilowatts of peak power through an 8-foot waveguide antenna array. The radar maintained continuous 360-degree scanning and could distinguish targets as small as a submarine's conning tower at ranges surpassing 150 miles under ideal atmospheric conditions. Initial testing at Quonset Point Naval Air Station in November 1942 produced results far beyond what engineers had predicted. Test flights using a captured German submarine showed that the ANAPS-20 could detect a fully submerged boat at periscope depth from 75 miles away when submarines surfaced to recharge their batteries. A mandatory procedure every 18 to 20 hours, the detection range extended to 200 miles. The key advancement came from signal processing techniques designed specifically for submarine detection. Traditional radar identified targets by size and reflectivity. The AAPS-20 used Doppler shift analysis to recognize movement patterns unique to submarines. Surface ships moved with steady speed and course. Submarines followed a distinct cycle: approach, dive, surface, charge batteries, submerge again. Dr. Harold Zee's signal analysis team at Fort Monmouth, New Jersey, developed classification algorithms capable of separating submarine signatures from surface ships, whales, and atmospheric noise. The radar tracked target movement over time, identifying acceleration patterns that no surface vessel could replicate. Production began at Western Electric's Kearny, New Jersey facility in January 1943. Each ANAPS-TSI-20 unit required 847 precision components, including the new magnetron tubes produced exclusively at Bell Telephone Laboratories. The entire system weighed 650 pounds and demanded significant aircraft modifications for installation. The TBF Avenger proved perfect for the job. Its internal bomb bay could house the full ANAPS-20 assembly while still allowing external hardpoints to carry depth charges or acoustic torpedoes. Although the radar required extra electrical power, the Avenger's Radar 2600 engine supplied more than enough capacity to support the system. Installation procedures required removing the aircraft's dorsal gun turret and replacing it with a radar antenna dome. Inside, technicians added 3 additional radio operator stations, signal processing consoles, and navigation plotting tables. Each modified aircraft became a flying radar station with immediate strike capability. By March 1943, 16 escort carriers were operating in the North Atlantic, each carrying 4 ANAPS-SD-20 equipped aircraft. Together, they created overlapping radar coverage across the primary submarine transit routes linking German bases to their Atlantic patrol zones. German intelligence remained entirely unaware of these capabilities. Captured Allied aircraft had been inspected, but the ANAPS-20 installations were classified far beyond anything German espionage could reach. No German agent had obtained information about airborne centimetric radar research. March 22, 1943. 0615 hours, USS Bogue, operating 300 miles northeast of the Azores. Lieutenant Commander David Harrison received the mission briefing that would determine whether 18 months of secret development could alter the course of the Battle of the Atlantic. Intelligence indicated a concentrated German wolf pack in grid square BE-47, threatening convoy O and S, one carrying critical supplies to Britain. The APS-20 equipped TBF Avengers had been operational for 6 weeks, but earlier contacts had slipped away before attack aircraft could reach firing distance. Today would mark the first fully coordinated hunter-killer operation using real-time radar tracking. Aviation electronics technician second class Thomas Scanner, Riley settled into the radar operator position aboard Avenger 23, call sign Bloodhound. His ANAPS-20 console painted 200 miles of North Atlantic Ocean as green phosphorescent traces circling across the scope. At 0627 hours, Riley picked up the first submarine contact, bearing 045 degrees, range 127 miles, contact designated Romeo 1. Riley transmitted, submerged submarine bearing 045, range 127 miles, estimated course 180 degrees, speed 6 knots. Within minutes, 3 more radar contacts appeared on the scopes of other aircraft. The predicted German wolf pack was revealing itself on American radar screens in real time. U-boats U-191, U-628, U-384, and U-447 were converging on convoy O and S-1, following standard Rudel tactic procedures. The German commanders had no idea they were being watched. Captain Lieutenant Heinrich Vabra of U-628 had orders to locate the Allied convoy and guide the pack into attack formation. His submarine held course 195 degrees at periscope depth, using the same approach strategy that had succeeded many times before. At 0645 hours, Weaver ordered U-628 to periscope depth for a routine navigation fix. The periscope stayed exposed for 38 seconds, long enough for the conning tower to bounce a radar signal detectable at 89 miles by Riley's equipment. Romeo 2 has surfaced, Riley reported. Bearing 038, range 89 miles. Contact is stationary, likely charging batteries or conducting periscope observation. Harrison coordinated the strike, issuing precise vector instructions to all 4 Avengers. Unlike older anti-submarine tactics that depended on visual spotting or sonar contact, the AAPS-20 provided continuous tracking data. German submarines could no longer disappear beneath the waves. Their routine surfacing cycles created radar signatures that exposed them every time. At 0703 hours, Lieutenant Junior Grade Robert Mitchell, piloting Avenger 31, made visual contact with U-628 at 4 miles. The German submarine was running submerged at periscope depth, completely unaware of the approaching aircraft. Mitchell's depth charge run was perfectly executed. 4 Mark 54 depth charges detonated in a precise pattern around U-628's estimated location. The submarine was forced to surface, its forward torpedo compartment severely flooded. Viber's emergency transmission, intercepted by Allied listening posts, revealed the chaos, under attack by aircraft with impossible accuracy. No radar contact detected. Request immediate tactical guidance. Simultaneous attacks struck the other 3 submarines in the Wolfpack. Within 47 minutes, German Naval Command had lost contact with all 4 U-boats converging on convoy ONS-1. For the first time in the Battle of the Atlantic, Allied forces achieved tactical surprise using technological superiority rather than numerical advantage, a psychological shock for the Germans. Within 72 hours, Gross Admiral Donitz's Operations Center in Lorient received reports of impossible Allied detection capabilities from surviving submarine commanders across the North Atlantic. Kapitän Lieutenant Heinrich Wehr, the sole survivor of U-628, gave testimony that challenged 3 years of German tactical doctrine. During post-rescue interrogation by Allied intelligence officers, Weber described attacks that seemed to defy physics. They found us when we were completely submerged. The aircraft approached directly to our position without search patterns. They knew exactly where we were. German submarine psychology had rested on a single principle: invisibility. Crews endured weeks of cramped, claustrophobic conditions, constant danger, and mechanical strain because they believed their boats were undetectable when properly handled. The revelation that Allied forces could track submerged submarines shattered that foundation. Radio intercepts decoded by Allied crypto-analysts revealed the depth of German confusion. On March 24th, U-Boat Command transmitted, "All boats report detection methods used by enemy aircraft. Impossible accuracy suggests new capability unknown to intelligence." By March 26th, multiple boats reported immediate aircraft responses to periscope observations and recommended an emergency tactical review. The psychological effect rippled through the entire submarine force. Crews who had once conducted routine periscope checks now treated every surfacing as potentially fatal. Battery charging operations, previously carried out with confidence at night, became exercises in terror. Kapitan Swaz Ibahatkote recorded the morale crisis in his operations diary. Submarine commanders requested permission to abort patrols. Crews reported being unable to maintain normal operations when detection seemed inevitable. Wolfpack tactics became impossible when individual boats could not remain hidden. German naval intelligence launched desperate investigations into Allied detection capabilities. Teams examined captured Allied equipment, interrogated prisoners, and analyzed every technical document available. They found references to improved radar systems but discovered no evidence of the revolutionary airborne capabilities actually in operation. The psychological effects proved as devastating as the physical destruction of the submarines. German crews began reporting phantom aircraft contacts, imagined radar detections, and obsessive concerns over electromagnetic emissions. Submarine commanders altered standard procedures, cutting back on periscope observations and extending submerged operations beyond safe limits. Medical officers at German submarine bases documented unprecedented rates of combat fatigue, nervous exhaustion, and requests for transfers to surface vessels. The elite submarine service, once the most prestigious assignment in the Kriegsmarine, faced recruitment difficulties for the first time since 1940. Most critically, German commanders started avoiding contact with Allied convoys. The aggressive tactics that had sunk millions of tons of Allied shipping gave way to defensive operations focused on survival rather than attack. Wolfpack formations scattered as individual submarines prioritized concealment over coordinated assault. By April 1943, German submarine effectiveness had dropped by 60% despite no reduction in operational boats. The technological revolution had sparked a psychological revolution, turning U-boats from hunters into hunted prey, fundamentally shifting the strategic balance in the Battle of the Atlantic. The destruction of Wolfpack Stürmer on March 22, 1943, had created a psychological crisis that spread through German naval command faster than the shockwaves of exploding depth charges. Within 72 hours, Gross Admiral Dönitz's operations center in Lorient received reports from surviving submarine commanders across the North Atlantic detailing impossible Allied detection capabilities. Captain Lieutenant Franz Weber, the sole survivor of U-628, gave testimony that challenged 3 years of German tactical doctrine. During post-rescue interrogation by Allied intelligence officers, Weber described attack patterns that seemed to defy the laws of physics. They found us when we were completely submerged. The aircraft approached directly to our position without search patterns. They knew exactly where we were. German submarine psychology had relied on a single principle: invisibility. Crews endured weeks of claustrophobic conditions, constant danger, and mechanical strain because they believed their submarines were undetectable when properly handled. The revelation that Allied forces could track submerged submarines shattered this foundation. Radio intercepts decoded by Allied cryptanalysts revealed the depth of German confusion. On March 24th, U-Boat Command transmitted, "All boats report detection methods used by enemy aircraft. Impossible accuracy suggests new capability unknown to intelligence." By March 26th, multiple boats reported immediate aircraft responses to periscope observations and recommended an emergency tactical review. The psychological impact cascaded through the entire submarine force. Crews who had previously conducted routine periscope checks now treated each surfacing as potentially fatal. Battery charging operations, once performed confidently at night, became exercises in terror. Kapitan Zuri Eberhard documented the morale crisis in his operations diary. Submarine commanders requested permission to abort patrols, and crews reported an inability to maintain normal operations when detection seemed inevitable. Wolfpack tactics became impossible when individual boats could not remain hidden. German naval intelligence launched desperate investigations into Allied detection capabilities. Teams examined captured Allied equipment, interrogated prisoners, and analyzed every available technical document. They found references to improved radar systems but discovered no evidence of the revolutionary airborne capabilities actually in operation. The psychological effects proved as devastating as the physical destruction of submarines. German crews began reporting phantom aircraft contacts, imaginary radar detections, and obsessive concerns over electromagnetic emissions. Submarine commanders altered standard operating procedures, reducing periscope observations and extending submerged operations beyond safe limits. Medical officers at German submarine bases documented unprecedented rates of combat fatigue, nervous exhaustion, and requests for transfers to surface vessels. The elite submarine service, previously considered the most prestigious assignment in the Kriegsmarine, experienced recruitment difficulties for the first time since 1940. Most critically, German commanders began avoiding contact with Allied convoys. Aggressive tactics that had sunk millions of tons of Allied shipping gave way to defensive operations focused on survival rather than attack. Wolfpack formations dispersed as individual submarines prioritized concealment over coordinated assaults. By April 1943, German submarine effectiveness had declined by 60%, despite no reduction in the number of operational boats. The technological revolution had triggered a psychological revolution, transforming U-boats from hunters into hunted prey, and fundamentally shifting the strategic balance in the Battle of the Atlantic.